This is a very practical problem. Jeffrey's running along a straight track, and the table below represents his velocity in feet per minute and selected values of t. So we're going to approximate the value of this. Okay, let's pause and think about what this is. The integral of velocity gives me displacement, but since I've absolute valued the displacement, the velocity, I'm going to get the total distance traveled. So that actually, before I even finish reading the problem, answers the meaning of this integral in the context of the problem. So final answer is going to be a number, and that's going to be how far Jeffrey ran. Now, it is an approximation, but it's our best guess. So we're going to approximate that value using a left Riemann sum with the extra credit if you can draw Riemann of the four, not the rectangles, but the man himself, with the four subintervals represented by the table above. Just draw James Garfield. They look like the same guy. Using correct units, explain the meaning of this integral in the context of the problem. So we are going to find the left Riemann sum, which will give us an approximation of this, but because of the absolute value, we're going to pretend like that's positive and that one. So our first rectangle is 8 units wide and 60 units high. 8 wide, 60 high. Our next rectangle is 5 units wide and 72 units high. Our third rectangle is 9 units wide and 65 units low, but you know what? That's okay. He was running backwards. He was running in a negative direction relative to the other direction he was running. And then 8 units wide and 80 units of height. And we'll just go ahead and crank out an answer. I'm not going to waste your time doing all that. So 2,065. 2,065 what? Well, what did Jeffrey do? Jeffrey ran, not exactly, maybe, but approximately, this is an approximation, 2,065 feet. Okay, we're going to find an approximation for A of 4. What's A? We'll keep reading. Jeffrey's acceleration. They defined what A is. We can sometimes assume that in our minds, but they need to define it, and so do you. In a context of a problem, you can't be like, well, A of t equals, and they're like, what's A? It's acceleration. You need to define it as such. Anyway, I digress. Find an approximation for A of 4. Jeffrey's acceleration at t equals 4 minutes. Oh, so we just need to find the derivative. You don't have an equation to find the derivative of velocity, son. So include units and explain your answer in the context of the problem. So because I can't find the derivative at 4, I can't get the instantaneous acceleration. That would be the acceleration at the moment. But what I can do is an approximation with the average. I hear the band playing. They're providing the soundtrack as we figure out the approximation. This is basically velocity of 8 minus velocity of 0 over 8 minus 0. That's what I'm really doing. And velocity is, in this context, feet per minute. That's minutes, feet per minute. So that's going to give me 12 over 8, which is 1.5 feet per minute. So in context, at t equals 4 minutes, Jeffrey's acceleration, paused, I'm like, is it 2 L's or 1? Oh, it's 1. Acceleration was approximately 1.5 feet per minute, or per minute squared.